myclass 4, 5, 6. So is I just remove these files from work, because whichever files we need, I have already copied to today's code folder. So 4, 5, 6, 4, 5, and 6. Okay. So myclass 4 first. Now here also, in case of myclass 4, myclass 4. I will not execute this code. I would like to give you some time for the diagram. So look at this code, draw the diagram, and come to the conclusion. What is the answer of this program? What will be the output of this program? For that, you have to draw. So do it. I'm waiting. 5 minutes.
हेलो
Yes.
सर, इसमें नम की वैल्यू बतानी है.
पूरा आउटपुट बताना है.
ओके.
And your diagram will give you the output. Okay, done?
Yes, sir.
So try to understand this code first. myclass 4, instance member num. Now, whenever you revise our discussion, Always, whenever you read any class, public class, my class 4, int num is equal to 100. Don't just say int num is equal to 100. Say that instance member int num is equal to 100. So keep on saying that. So that will make your concept clear. If you see anywhere static member, you say static member or you say class variable. Okay. So instance member num 100, void display which displays 100. Void a fun one. Fun one is a method which takes k, which takes integer int k, and that k we change inside the function. Then in main function we create object of my class 4, we call display, we call fun one. Since fun one's requirement is int, we pass m1.num. Here for the time being we can access that num in the main function, because we are in the same class. So we pass m1.num, that num will go to k and we change k over here, and then once again we call display. So check your diagram and check your output also. First of all, we create object of my class 2. The way I draw diagram for each and every example, you draw diagram for your revision also. It's none. Object of my class 4. What's the value? 100. M1 dot display, answer 100. M1, sorry, M1 I did not mention. M1 is a reference. So M1 dot display 100. Then we call M1 dot fun1 and we pass M1 dot num. When we pass M1 dot num, that we collect in a K. Now K is a local member, so we know where local member is stored. Local member is stored on the stack. So when you pass M1 dot num and when you collect it inside K, K has got 100. K has got that value which M1 dot num has got, that is 100. And then K is equal to 200. So you change K. When you change K, what happens? 100 will go, 200 will come. Fun1 function over. When function fun1 over, K will be destroyed because K is local. So K will be destroyed. And then you come back in main and you say M1 dot display. M1 dot display, M1 dot display is 100. So output of this program is
100.
100, 100. 100, 100. Call by value. When you pass M1 dot num to K, and when you change K, you don't change num. So within a function, whatever action you perform, that is operated on the K. So this is called as call by value concept. Is that clear? Okay. If it is clear, then my class 5. 100, 100. My class 5. Once again, I would like to give you time. Yeah. Look at the code, draw the diagram, and find out the answer, output of this code. Yeah. Here we have a difference, small difference, but very important difference. Just be careful with that fun one. Huh? Okay, let's check. This time the difference is fun1. In our last example, fun1 was accepting int. Since fun1's argument was int, we had to pass int. So we pass m1.num. But here fun1's argument is not int, it's myclass by reference. So when fun1's requirement is reference, while calling fun1 we have to pass reference. As simple as that. When your requirement is primitive, you pass primitive. When your requirement is reference, you pass reference. So let's see how does it work. Yeah. This is my class 5 object which you create here. Num is 100. M1 dot display 100. M1 dot fun1 M1. Why M1 you are passing? I repeat, because here requirement is my class 5 reference. Now understand one very important thing here. When you call fun1 by passing M1, M1 goes to ref. So internally it becomes my class 5 ref is equal to M1. Now this statement you know very well. This statement you know very well. This is new for you that you are passing reference and you collect in a function. But this statement you know, we have discussed already. When you pass M1, that gets collected in ref. So internally it becomes my class ref is equal to M1. Now my class 5 ref is equal to M1 means ref is a reference to that object where M1 refers to. So ref is a reference. Ref is a reference. We'll have some address here. Okay, my class, you're passing M1 and that gets collected in ref. So internally, my class 5 ref is equal to M1. That means ref refers to that object where M1 refers to. So ref refers to the same object. Same object. And now you are saying ref.num is equal to 200. Ref.num is equal to 200. Now look at the diagram. Whether you say m1.num or you say ref.num, both are same. Ref.num is equal to 200 means this 100 will go, 200 will come. 200 will come. After fun1 is over, you know local variable dies as soon as method is over. So once fun1 is over, ref will die, ref variable will die. That means ref reference will go. But that will not create any problem for this object because this object is still referred by M1. So there is no problem with the object. This object will not be marked for garbage collection. Now you say m1.display. What is m1.display? What is m1.display now? Look at the diagram. 200.
200.
200. 100, 200. Output 100, 200. This is the diagram. Check your diagram. Is that correct? Did you follow?
So can you explain the reference diagram?
Reference, ref refers to the same object where M1 refers to. Because when you pass M1 to ref, internally it is my class ref is equal to M1. Since we have already discussed this concept, it was helpful for us in this example. We just had to understand when we pass M1, when that M1 is collected in the ref, internally this statement becomes my class ref is equal to M1. So M1 refers to one object, ref will refer to the same object where M1 refers to. My class 5 ref is equal to M1 means that ref refers to that object where M1 refers to. So it's here. Now whether you say m1.num or ref.num, it is going to affect the same num. So that's what happened.
Yes. Thank you, sir.
Still, this concept is called as call by value. Now myclass 6, which is same as myclass 5 but with